Hey everyone, welcome back to the lab. In this video, we're going to be continuing on our investigations of performance into F# Web APIs built with Giraffe, this time with a 1% improvement. So first we're just going to give a quick overview of F# Giraffe so we kind of understand the technologies we're talking about today. Then we're going to go quickly into benchmarks so we kind of understand where these numbers and measurements are coming from. And then finally, we'll go into the 1% fix that actually led to these change in measurements. So first, F# and Giraffe. So this is currently my favorite stack for building web APIs. F# is a programming language. It's functional first, but it really focuses on productivity with conciseness, its type system, all sorts of things. And also has a great ecosystem through .NET, which means you basically get all the power and libraries that the C# people, which is, top 5, top 10 languages in the world have been building. Giraffe, which is actually the web framework that we're building on, essentially gives you all the best power of the C# web server ecosystem through ASP.NET, but it does stuff in such a way that you get all the power of F# through its functional bindings, very lightweight, low boilerplates, and basically makes it so you never have to leave the niceness, the ergonomics of F# even as you dig into your web framework. Digging more into these technologies is out of scope of the video, but I do have this video if you want to learn more and kind of see what a simple, performant web API built with these technologies looks like. So I'll have a link here and in the description. Okay, so now that we kind of know the technologies that we'll be testing and measuring and changing in this video, let's also talk about how we are going to be measuring that, and that's via benchmarks with an asterisk. So all benchmarks have an asterisk, all measurements have an asterisk, and I just want to make it very clear so that we understand where these percentages are coming from. So first I want to say that I believe benchmarks are useful because this is really how we are even able to compare technologies across a lot of the different perspectives that we actually care about in the real world. They're not perfect, but I don't know if we have a better way to do this yet. Specific ones that come to mind that I think are very useful is that we're basically trying to automate and standardize the way to test these technologies against different use cases and workloads. As we come up with new ones that we decide are normal or prevalent, we can add to those. Other cuts around patterns. So even if you choose different technologies, there's different ways to put them together. And finding standardized ways to see how those actually work together is really useful as you get into the huge combinatorial opportunity space of what you can actually build. And then finally, across all the different metrics. There's probably going to be 5 metrics that people really care about in each area, but depending on your use case, there could be a huge long tail of metrics that you need in a specific use case, and really benchmarks are the only way that we can do that at scale. For those new to the benchmarking ecosystem, this is kind of what it looks like. This is an example of Tech Empower, one of the most popular ones for web frameworks specifically, which is comparing over 100 different web frameworks across all these different cuts that I talked about earlier. You can check it out at the link here and also have it in the description. But the reason I wanted to bring this up really is to show that while it's super useful, we do really need to be careful about how we actually use this information, and that's because good benchmarks are hard, both hard to find and hard to build, and this is where the asterisk comes from. The main 3 reasons I can think of why this is the case is first just consistency, both in how do we actually standardize these tests across benchmarks, how do we be fair to all our test subjects, and then again also how do we make sure that the test subjects are actually doing the same thing? How do we know they're actually consistent across each other? The second one is around authenticity. How do we know that this benchmark standard is actually authentic to the real world? How do we know that the test subjects are actually authentic to the real world? And then finally, misaligned incentives, because a lot of times most incentives are actually to game the benchmarks, not to make the benchmarks better. That's a quick overview. There's plenty of blogs on this that you can look up, but that's all I'm going to go into in this video so we can kind of move on into the fix. We do talk about this a little bit more in my previous performance investigation into F# and Giraffe, so if you're curious about that, you can check that out. We've also got a lot of links in there to more deep dives into the problems with benchmarks. But let's move on into the 1% fix. So the reason I talked about those asterisks and the previous fixes is because that's kind of what leads us to the first fix. So in the previous fix I made, basically the reason I even realized something might be wrong is because I was looking at the benchmark or benchmarks linked here, and I realized that Giraffe was running pretty slow. It was near the bottom of all of the F# web framework results. Now I've followed Giraffe for a while. It's been my web framework of choice for a while. And so my mental model is always really fast because it's always performed very well in these benchmarks and in my own projects. So seeing it here was a little bit alarming. But sometimes that happens. Maybe I was just wrong. But what really kind of stuck out to me as like probably wrong with the tests, maybe not the actual technologies, was that I saw Saturn sitting about 3x faster than these benchmarks. That was weird to me because I happen to know that Saturn is built on top of Giraffe. And so whenever you have a derivative of something or you build something on top of something else, you usually expect that thing to either not gain any performance at all or to actually lose some performance just due to abstraction overhead. If it was within 10 or 15%, maybe I could have lived with it, but 3x is like a lot. And so the change I made there was to remove logging, which removed a lot of the I/O that these servers were doing, made it more consistent of a benchmark with all the rest of the ones, and eventually led to the results of improving the worst of them Giraffe endpoints by 6.5x. Again, we're not going to go into details for that. You can check the previous investigation for more info. But I wanted to start there because this leads into the current performance improvement. And the way that I found the previous one was basically by just looking at what all these benchmarks were doing, especially the ones around .NET, so the C# and F# ones, and kind of just trying to see what they were doing differently to make sure that these actual test subjects were being consistent with each other. And while the logging thing was the largest opportunity I found, it wasn't the only one. And that's how we lead to today's 1% fix. And the change that I made, and this is from the PR linked here, is to change this Kestrel configuration to remove the server header. And when I did this, basically we can see about a 1% increase in both Giraffe and Giraffe endpoints respectively in terms of requests per second. Now I'll note that this is very small and it might not actually be statistically significant, but what I'm going to argue in the next slides is why this makes sense as potentially leading to performance, and even if it doesn't actually lead to super measurable performance increases, it's at least directionally an improvement, and you should use it too. And so here's what this thing actually does. So by default, any web server running ASP.NET, which is again what Giraffe is built on top of and uses by default, any Kestrel server is going to add this default header in its response. And this header basically just says, this is the server type that I am, and I am Kestrel. Now this is odd for a few reasons. One, because nobody actually needs to know or probably should know what server you're running. And two, this probably required some sort of overhead to actually populate. Maybe not much overhead, but some. And so when we set this default server header to false, we actually have a few implications. So when we're overriding the default, but for most people, as I mentioned, it probably doesn't matter because the server header shouldn't be used for anything. Though if you're running IIS, I have heard it does do that, but probably shouldn't be using IIS. But the implications for this are kind of twofold. The first is performance. So this is an unnecessary server header that you don't need to set and you don't need to send in the payload. But because you are, this is adding some probably minuscule amount of I/O and network load on each of these requests. Probably in the real world, when your requests are doing like actual work, this is going to be an extremely negligible magnitude, but definitely in benchmarks when we're actually doing nothing but probably returning a very small string, this can have some noticeable effects, maybe not proven by the results we see today. But the second implication is probably even more important for us, even though measuring its magnitude is going to be a lot harder. And that is with respect to security. So as we mentioned, this information is unnecessary, so it doesn't really serve a purpose. But what we are doing is we are leaking information about what is actually running on our server. And now this doesn't necessarily make our server less secure. It's still just going to be as hard to break into, but it does give more information about what kind of thing we're running and therefore what kind of vulnerabilities we might be open to. I kind of think of this in the same way as leaking what bank you use. So if I link to you the bank that I use, you still have to break into that bank, which is probably still very hard. But it makes it a lot easier for you to check for vulnerabilities because now you're not guessing what bank I use. And that's the kind of thing I see here. And so to some, because these are probably very negligible magnitude changes, I wouldn't expect this to really be measurable if you were to implement them. But because directionally they are going in the right direction and there's not really any downside to it, I do think everyone should probably remove this header. And of course, to put my money where my mouth is, I've already made the change to implement this in Cloudseed, which is my F# Svelte Kit boilerplate that I use for all of my projects. This is basically the simplest, most scalable, most maintainable foundation I found for spinning up robust services quickly. And so it contains this optimization plus a ton of other ones that I've made while working with F# and Giraffe. So if you're curious about this, I have a video showing you how to get up and running with it, as well as an overview of what everything is included. So check that out if you're trying to build some scalable F# services fast. That's it for this video. So let me know if you have any questions, particularly around F#, around Giraffe, around web APIs, anything like that. Happy to answer them. And as always, this is where you can find me. So thanks for watching this video, and I will see you next time.